My name is Bart Preneel. I'm professor at the University of Leuven and I work in the electrical engineering department. I'm head of the research group COSIC, which works on information security and privacy and embedded system security. What we try to do is to create secure interactions in the digital world. So for a long time we've been doing research on cryptographic algorithms and protocols that allow the secure interaction, that allow to keep our data safe. We also look at a broad range of applications, such as identity management, social networks, wireless systems, sensor nodes, and so we try to build secure solutions for this. But we have a specific approach where we start from the mathematics and the crypto and we try to expand this to complete systems and look at the security of systems. And we also have unique expertise in-house because we have hardware expertise, so we can actually also build secure systems and decide at which layer of the system we integrate the security. People use more and more computers and more mobile phones, mobile devices and tablets, and the next step will be IoT, Internet of Things, will be small devices that are integrated everywhere. And to some extent this exists today. A modern car today has 70 to 80 processors that talk to each other over a network. But in the future, in fact, all those things will talk to each other. We also get processors inside buildings, inside the environment, and also in manufacturing sector. And so there's clearly big challenges in securing this. Once you put everything on the internet, what you get is a much larger attack surface, which means that many more organizations are capable of connecting to your networks and systems and actually trying to hack them or try to obtain private or sensitive data. And so what we try to do is try to make those things more secure by developing solutions. Our core of our expertise is developing encryption technologies, authentication technologies. So we have quite some expertise in there. Some very widely known algorithms have been developed in our group. So we try to study the security of existing algorithms and develop new ones. But we also look at protocols. How can you authenticate somebody in a friendly way? How can you authenticate using biometrics? How can you authenticate a chip using chip biometrics? So we have a whole range of techniques we use to actually build more secure systems. And then we also look at the application side. For example, how do you do identity management? How do you do secure payment? And in particular, we also look at implementation security. So it can well be that your system is secure from a mathematical point of view, but if you do physical attacks on these devices, in fact, you actually can break them. And some of these attacks include power attacks, where you measure the power consumption of a device, or electromagnetic attacks, where you hold up a small antenna against the device, and then you can measure what's inside the device and actually find security parameters, keys, and actually break the security of systems. What we try to do is study how big this problem is, and we try to develop solutions for this kind of attacks. Also, we like to come with innovative solutions where we rethink the architecture, rethink the way of doing things. So in the current cloud paradigm, the model is that you send everything to the cloud, you do analysis there, and then you make decisions and you send those back. What we like is more distributed architecture where most of the data stays locally. This is more performant in terms of bandwidth and energy, but also more privacy friendly. In fact, you can do operations on data locally, and if needed, contact the central service and give it minimal information. And if you put data centrally, we work on techniques to encrypt it, but that you can still do operations on it. So on the one hand, it's encrypted. On the other hand, actually, you can still do computations on the encrypted data. So these are new things which did not exist 5 or 10 years ago. Well, iMinds is a very strong research center where we have many partners to collaborate. So we are one of the 3 partners in the iMinds security department. And iMinds provides essentially two types of funding. The one is the more basic research, where we actually develop a research agenda for 5 years, strategic agenda, where we actually have the time to think about the problems and work for the long term, 3, 5, 7, 8 years in the market. We can think on solutions and do this. On the other hand, there is the ICON trajectory and mix, where we actually work on more short-term projects with industry partners, where we have a time horizon of 1 or 2 years and things end up with a demo. And then, of course, iMinds is a very interesting ecosystem where you also have support for spin-offs. People can interact with each other, like you have the iMinds conference, SuperMinds. You have all these opportunities for young researchers to develop their career and to get in contact with industry. Because in our group, it always has been very important to do theoretical research, fundamental research, but also bring it to the applications. And iMinds is a very important factor in helping us doing that. It's, of course, very difficult to predict what's going to happen in IoT. I think in terms of technology, we know what's going to happen. There will be more and more sensors will be put everywhere, also put in our bodies. I think inside our bodies. In the end, it will also extend our brains and maybe our brain power. Of course, we get sensors in our buildings. We have already quite some sensors and computers in our cars, but there will be even more. We already get also in cities, at the city scale. So in fact, we get more and more computers, and people argue about how many it will be, but I don't think that's the core question, whether it's 50 billion or 100 billion. But those all will be connected, and they will enable new applications. So on the one hand, our main concern is how should we architect this that we don't have privacy disasters or security disasters, that in fact those things cannot be hacked or taken control over by other people, that we can actually keep the values of our society protected while having all these interactions. And on the other hand, of course, there is a big challenge to make it all work, to identify applications where security and privacy are an enabler.